Today, we're going to review some of that vocab from yesterday, and then we're really not learning any new vocab. We're just adding on to what we already did. So if you were not here yesterday, let's just review what we're talking about. We're talking about transversals, which are lines that intersect two or more lines. So in this diagram here, our line T is our transversal. It intersects those two lines, M and N. And when we have two lines being intersected that are parallel, we got a bunch of different properties. That's what we talked about yesterday. I'm going to scroll back to yesterday's notes for a second. In all of these examples that we did yesterday, we decided that we had to have parallel lines in order to say something about angles, whether they were congruent or supplementary. We call those the regular old conditional, right? P implies Q. Well, it is also true, because these statements can be biconditional, that the reverse is true. That's our converse. So our conditional statements in this box here from yesterday say that, I meant to do highlighter here. If it is true that the lines are parallel, then we can say all of this stuff about the angles. Notice we are always starting with information about parallel lines. Parallel lines imply something about the angles. If angles are parallel, if lines are parallel, then something else. These are if-then statements. What we are going to add on today is the reverse of that, the converse, which states, if I know something about these angles, then that must imply that the lines are parallel. So angles imply parallel lines. Or if something about the angles, then lines are parallel. Do we see how they are if-then statements? Okay. These 10 justifications, which are essentially the same 5 backwards and forwards, this is what we are eventually going to be putting into our proofs, like our 2-column statement justification proofs, like what we did last unit. So you will need to understand how to write these statements out just like this, like pretty much verbatim, like that. Okay, that's what goes into our 2-column proofs. So let's look at what this looks like. I'm going to use 2 different colors to kind of indicate what my hypothesis is, what my conclusion is in all of these following examples, just so we can keep track of what's going on. So take a look at these first 3. So number 1 says, if angle 1 is congruent to angle 5, then blank because blank. What I am starting with in this problem is information about my angles, which means I'm going to be using the converse, that right-hand column, justifications for the next few parts. So it says, if angle 1 is congruent to angle 5. I'm going to highlight those 2 angles. Remember, when we start these problems like we were doing yesterday, it's important that we identify what our transversal is and then what our parallel lines are. The transversal is the line that is shared between the 2 angles. So the one line that is shared by 1 and 5 is line A. That's my transversal. If those 2 angles are congruent, then can we say something about our parallel lines? Well, first, what's the relationship between those 2 angles? What would we call those? One of our 5 reasons up here. What are 1 and 5? Caitlin? Yeah, they're corresponding angles. Perfect. They're in the same location on that intersection, like the northwest location. So if corresponding angles are congruent, then lines are parallel. That is one of my reasons, so I can use that here. Which 2 lines are parallel? What do we think? If A is our transversal, what 2 lines must be parallel then? Yeah? Yeah, N and M are our 2 parallel lines. We write that literally by saying N parallel to M, like that. And then our justification, I'm copying it from up here. I started with corresponding angles that are congruent. It implied that lines were parallel. So we use corresponding angles congruent implies parallel lines. Does that make sense what we're doing here? If it said that angles 1 and 5 were supplementary, we could not use corresponding angles are congruent implies parallel lines because corresponding angles weren't congruent. They were supplementary, right? Okay, let's move on to the next one. I'm going to erase my markings. We're going to start all over. Number 2 says, if M is parallel to N, then 4 is congruent to blank because blank. So this is the same question in 2 and 3, which maybe hints that there's more than one correct answer. Hint, hint. So I'm starting with M parallel to N. That is my original conditional. I have the parallel lines. What can I say about the angles? So let's look for M and N. And then I'm going to also circle angle 4. Oh, maybe I use a different color here. Angle 4 is then congruent to what angle? Casper. It is congruent to 2, but not for one of our 5 reasons. We could say that it's congruent to 2 because of vertical angles, but would we need those parallel lines to be true in that case if we have vertical angles? No, which is a really good point. Okay, vertical angles, yes, they do still exist, but we don't care about them when I'm trying to prove parallel lines and stuff like that. What other one is it congruent to? Yep. Yes, Y6. Perfect. We start with parallel lines imply that alternate interior angles are congruent. Perfect. Now I have a second one. Can we find what that second one is? Anna? Y8. Perfect. Again, parallel lines imply corresponding angles are congruent. Questions there? Okay, flip it over. Same diagram. I didn't even change my diagram. We're using the same one. It says in number 4, if angle 4 is congruent to angle 10, that means I'm starting with an angle. So I'm looking at that right-hand column again. Then blank. So I'm starting with something about the angles in order to prove something about parallel lines. I'm going to highlight where angle 4 and angle 10 are. Then I'm going to figure out what's my transversal. M, N, A, or B is my transversal. Which one? Caitlin? Yes, because they share N in common. That's my transversal. What's the relationship between 4 and 10? The angle relationship between them. Kaylin? Alternate exterior angles. Do we have a proof reason that says if alternate exterior angles are congruent, which it says right here, then lines are parallel? We do. Which 2 lines are parallel? Anna? Perfect. A is parallel to B. Because, make sure we're writing this in the correct order, alternate exterior angles congruent imply parallel lines. Our reasoning, our justification should mirror this original statement. It says, if angles, then parallel lines. It should mirror that. We shouldn't have anything flipped. Okay, number 5. If A is parallel to B, then angle 4 is supplementary to blank. So now I'm starting with my parallel lines. A is parallel to B. That means I'm looking in the left-hand column on that table up there. It says angle 4. So here's angle 4. What transversal am I looking at? Anybody? M, N, A, or B is my transversal. Anna? Perfect. So any angle that I pick here to fill in this blank is going to be on this transversal, but not in the same intersection. So my only 4 options are 9, 10, 11, and 12. Kind of narrows down my choices, right? 4 is supplementary to which one? Anna. Why? Perfect. Excuse me. Write your proof reason. Parallel lines imply same side exterior angles supplementary. Any questions on those? Okay, I'm going to get a little tricky on you. Look at number 6. Excuse me. If angle 6 is congruent to angle 10, then blank. Again, I'm starting with information about my angles. So let's look there. Here's 6. Here's 10. What is my transversal? What one line do they have in common? And I'm hearing crickets because there is no line that they have in common, right? We see that. 6 and 10 don't have a singular line in common. In a regular proof, could we go multiple steps and try to figure out why 6 and 10 are congruent? Sure. We could get there probably through 2 sets of corresponding angles, easily. But if I'm just trying to justify this in one step to say 6 and 10 are congruent, that must imply parallel lines, I can't do it. Okay, I don't have enough information between 6 and 10. They don't even share a transversal. So I would say for this one, I have nothing. I can prove nothing is parallel based on just those 2 angles alone. And I got nothing over here. It's possible. It happens. We have to make sure that we're paying attention to whether they share a transversal or not. Okay, questions on that? Number 7 says angles 13 and 15 are congruent. Again, I'm starting with information about my angles. Let's look at 13 and 15. Are those 2 angles congruent? Yes. Why are they congruent? Is it one of these reasons up here? No. We don't even have a transversal. Once again, they don't share just one line in common. Remember, a transversal intersects 2 different lines. So 13 and 15 are congruent because of vertical angles theorem. But that still, once again, does not help me prove that those 2 lines are parallel. I cannot use that justification, 13 being congruent to 15, to say that lines are parallel. We can justify that 13 is congruent to 15 by the vertical angles theorem, but that does not prove parallel lines. Something else you might see, vertical angles, very common. Something else you might see would be like these 2 angles, 13 and 16, being supplementary. We know that visually because they form a straight line, but linear pairs, straight angles, do not prove lines parallel. So while things might be true, we're not saying whether they're true or not. We're saying whether they imply parallel lines. Okay. Are we okay if I skip the last one? Because it's just an easy one. Nice and easy. Good? I'm also going to skip number 9 because we did something like that. Let's look at number 10. We're going to move away from our justifications just a little bit. I'm still going to try to justify what I'm doing, but let's do one where we're actually solving. Take a look at this diagram. I have X, Y, and Z. Some of them are easier to find than others. What can I do first? What can I find in this diagram? I got 2 pairs of parallel lines here. Caitlin. How do you know that? Yes. I'm actually going to write that as its proof reason. Parallel lines imply corresponding angles are congruent. Perfect. I need to fill that in, though. How am I going to figure out what either 2y or x is? Anna? Why do you know that? Perfect. Again, parallel lines are implying same side interior angles are supplementary. So I could say that x plus 106 equals 180, or x equals 74. Which means, because of what Caitlin told me just a second ago, that 74 equals 2y. So this is 37, I believe. So I've got x, and I've got y. How am I going to find z? What ideas do we have for z? It might not be super obvious right up front. Yes, yeah. How do you know? Multiple steps, though, right? How do we know? Where can we put the 106 first? What other angle is congruent to the 106? Up here? Okay, so 106 is here and here because of corresponding angles. Let's do it like this. Corresponding angles, congruent. And then how do we know that these two are congruent then? Same reason, right? Different parallel lines, but still corresponding angles. So 106 equals 4z plus 6, or z is 25. Does that sound right? I think so. A lot of different steps here to find these three angles. Notice how in that blue to find z, I had to kind of move my angles around a little bit. That happens a lot. Questions on that? Okay, 2 more, I promise, and I'm done. This is like our warm-up. We have 2 clear parallel lines, here and here. I have to pick my transversal. I have 3 options here. I have the one on the left, the diagonal through the middle, or the one on the right. I have a couple different options here. To find x, it's probably clear that we do this center so that we can share a transversal between those 2 angles. Would we agree? These 2 angles are alternate interior angles. So 3x must equal 5x minus 20. Or I think x is 10. That one was pretty easy. How do we get to y, though? I heard 2 different reasons last hour how we could get to y. Anybody got one? Ooh, tricky. Like we did on our warm-up, we could use the triangle. Do you see that triangle on the left-hand side? If I plug in these values, I know that this angle is 30, right? Plugging in x. So then, is it okay if we say that this triangle right here adds up to 180? 4y plus 2y plus 30 equals 180. And I think that gets me y equals 25. Yeah. Are we okay with that? Can I show you another way we could have done it that I didn't even write down, but last hour pointed out to me? So maybe they're better than me. Who knows? What if I use this guy as my transversal? Okay, I'm going to ignore this transversal right here. Well, I know that same side interior angles can be supplementary, right? So what if I say that this is supplementary to this, which means they add up to 180. So I can set up basically the same exact equation. 4y plus that entire angle, 2y plus 30 equals 180. Same equation, same answer. Multiple different ways to get these things. Questions on that? Okay, one more, then I'll leave you alone. Pop quiz on what we did yesterday. Do we remember how we start these problems? We got to get a little bit creative, right? What do we have to do here? Casper? Perfect. Through the center, we add another parallel line. That is essentially splitting angle X into 2 parts. Let's call those parts A and B. I'm going to find each one of those parts separately by extending these transversals. What is angle A? It's angle A. Casper. Why? Perfect. What's angle B? Let me extend this transversal. Almost done. Give me one more answer here. What's angle B? Yeah. How'd you get it? Because what are these two angles? Same side interior angles are supplementary. Perfect. So I add them together. A plus B to get X, which is 62 plus 36, 98. There we go. All done. Any questions?